webinar from IFS. IFS is an aerospace and defense specialist. My name is Espen Olsen and I will be your host today at the Aircraft IT webinar on the 30th of April 2015. IFS is a global company. We're a leading global software provider established in 1983. The product IFS Applications is a fully integrated modular product suite, and we have a reputation amongst our clients for service excellence. Today we are represented on 5 different continents and in some 60 countries around the world. In aerospace and defense, IFS focuses in 4 different segments. We have a military segment looking at the land, sea and air domains within a military defense force, where we provide then optimization of fleet of assets, engineering configuration and maintenance, as well as military logistics support. The focus in this webinar is around civil aviation and more specifically the engine overhaul capabilities we have within our product suite. In addition to engine overhaul, we also support aircraft maintenance, complex assets, component repairs, refurbishments and upgrades, as well as maintenance planning. The third segment IFS focuses in A&D is obviously in the manufacturing areas, where aerospace and defense manufacturing companies provide product lifecycle management, manufacturing strategy and execution, product data management, customer relationship management, as well as corporate social responsibility. And lastly, the in-service support organizations, whether that is a small MRO shop or a larger OEM that provides in-service support to their clients. Enterprise asset management is key, as well as maintenance, repair and overhaul. Contracted logistics support, as well as performance-based logistics are some of the key elements in that product offering. 30 years in the business, we have grown to be one of the industry's most trusted partner. ARC has nominated IFS as the Aerospace and Defense Enterprise Asset Management Market Leader for 8 years running. One of the main reasons why IFS is regarded a market leader in aerospace and defense is because IFS is focusing specifically in this industry. We also have a special center of excellence with expertise, resource, competency that supports the global operations. The A&D Center of Excellence provides sales support to local offices. We provide strategic counseling to clients around the world. We also bring in specialized competency from the industry and from the end users. We provide thought leadership on various subjects relevant to the A&D market. We overlook and manage partnerships relevant to our A&D offering. And together with our research and development unit within IFS, we enhance the product and provide new developments in areas important to aerospace and defense. An important aspect of what we at IFS focus on together with our clients is trying to resolve some of the challenges that the civil aviation market is facing today. First of all, it's a very dynamic market. We see the introduction of new equipment, new aircraft, new engine models, and the maintenance impact of those new equipment types. We see that the OEMs is trying to increase the footprint in the MRO market as well. And we see that these fast changing requirements is affecting upgrades on equipment. Furthermore, we are also seeing a dramatic increase in production over the next 20 years. In order to support that growth, you need to also be able to have an IT system that supports that business. We see that the MRO services and supply chain is challenged to meet the OEM and the airline demand. Scarce support resources is also a requirement for our clients. You need to manage the resources and skills better. You need to optimize the MRO as a main cost driver to increase your profits. And finally, we also see that regulatory requirements is important. You need to apply by the maintenance standards. We see the introduction of export control, eco-footprint, and health and safety as important aspects and critical for the civil aviation clients to to meet those requirements. In civil aviation, where we typically deliver value is in the maintenance areas. If you look at this aircraft, it's a hypothetical flight with 100 passengers, where 29% of the seats will pay for the fuel, 20% will pay for the salaries, 16% will pay for the ownership costs, there's 14% that goes to government fees and taxes, and then there's 11% that goes into maintenance. Only one seat represents the profit that the airline is looking at. If you then are able to reduce the maintenance costs, let's say by 10%, you're then doubling your profits. In maintenance, repair and overhaul, and there should be no surprises to the audience on this webinar, asset management is critical. The main cost drivers in aerospace and defense is within the logistics. It is the management of the fleet, it is the maintenance of the asset, it is the optimization of the supply chain, and it is within the efficient use of the personnel you have at hand. Our best practices drive efficiency in the logistics areas, cost savings and inventory, and supply chain management. IFS Applications is a product that we, IFS, provide. It is a solution that is created by IFS, it's been developed by ourselves, it is maintained by IFS, and it's delivered by IFS. So all from one supplier. IFS Applications is built on modules. We have a foundation layer that is our technology layer at the bottom, where all the architecture and technology is stored within that layer. On top of that, we have some generic modules that support accounting rules. It's a generic interface to either IFS financials or any other financial package that you may have within your business. Sustainability management, lifecycle management, document management, business intelligence, quality management, case management, and process models. They're all available throughout the application and generic modules that you can use to extract data from the production transactions that you have. On top of the gray layer, we have the functional module stacks. IFS Financials contains a number of specialized modules. We have IFS Human Resources, IFS Engineering, IFS Projects, IFS Manufacturing, IFS Supply Chain, IFS Sales and Service, IFS Maintenance, and Business Enablers. Within each and every of those functional stacks, there is detailed functionality stored within the modules. The beauty of IFS is that you can deploy independent modules to meet your specific business requirements. It means that you can pick and choose from these stacks to configure your solution. It also means that if you don't need financials, HR, or business enablers, sales and service, you don't install that. You only install and purchase what you require. And then you can build on later on when you feel fit and ready to introduce new additional areas. The focus for today is going to be within IFS Engineering, it's going to be within IFS Manufacturing, IFS Supply Chain, as well as IFS Maintenance. And last couple of slides I will cover in this intro session is around some of the clients that we have in the aerospace and defense marketplace. The total amount of clients is about 100 A&D clients around the world. Some large corporations, others that are smaller MRO shops or smaller manufacturers. We have been implementing the engine overhaul solution that we're going to focus on for the next 40 minutes with companies such as Emirates, GE Aviation, Hindustan Aeronautics Limited, and Alitalia Maintenance Systems, as well as with GA Telesis, what previously was known as Finnair Technical Services. My good colleague Andrew will take you through the complex assembly MRO flows. That is what we call the engine overhaul solution. And also Roel Prins will take us through the corporate performance management areas supporting the engine overhaul business. So with that, I hand over to Andrew Stimson. He is currently living in Dubai, working with our project at Emirates.
Hello and welcome to the IFS webinar on the use of the complex assembly, maintenance and repair overhaul software. This software is mostly used to control the maintenance of aircraft engines and APUs, but can also be used for other complex sub-assemblies such as landing gear. What we're looking at here is the high-level solution overview of the Camro software, and it's devised into three major sections. In the middle we have our core production process, and it's essentially divided into multiple gates. Gate 0 being the work scoping and engine induction, Gate 1 being the disassembly and disposition, including cleaning and inspection activities, Gate 2 being split between internal repair, if we're having any components that we're repairing through our own back shops, or procurement and marshalling processes for material that we're procuring outside the engine shop. Gate 3 is assembly and test, and Gate 4 being split between customer invoicing and work pack production. Along the bottom of the diagram you can see what we call supporting processes. These are human resources management, tooling and equipment management, supply chain, inventory management, finance and facility and IT management. Again, these are fully supported through the IFS solution. And across the top we have a number of management processes. So let's get started with the Gate 0 process. The prerequisite to creating our initial work order and our induction inspection work scope is that we have an engine serial number assigned. And as you can see in the component live screen, that's what I've done here. We have a part number, identifies the engine type, the serial number, and the time and cycle data, which is supplied by the customer. To create our initial work order, I go to my shop visit screen and start the create work dispatch and receive order process. So there's a few default pieces of information I need to record here, including the user ID, the work scope, the organisation that will be performing this work, and the anticipated start and finish dates of the shop visit. If I skip through to the next process, I can now link it to a customer agreement ID, which will define the contractual terms for the shop visit, a coordinator who will be responsible for the receipting and the dispatch of the engine, and finally the actual engine serial number that we will assign to the work order. The last page of the assistant is where we define whether we want to create just a work order or also a dispatch and receipt order to facilitate bringing the engine into the facility and then dispatching it once the work is actually completed. And as you can see, we now have our work order, dispatch and receipt orders all created. So the next step is going to be for us to go and actually set our incoming inspection work scope and produce the shop floor documentation to control that part of the shop visit. So if I navigate to my define work scope window, if I expand out my tree navigator, which gives me a graphical representation of my engine structure, I'm going to select the calculate maintenance level from baseline option. And in this case, we've set the incoming inspection maintenance level as the baseline for this type of engine shop visit. And that's represented, as you can see, against the 720000 position part, we have a maintenance level of incoming inspect. I can now release the work scope to create the shop orders for the shop visit, which will also print out the incoming inspection shop floor documentation. If I now navigate to the interim order structure window, I can see the structure of shop orders that has been created for this shop visit. And in this case, it's a very simple structure. As you can see, a single disassembly where we're going to have our operations for our incoming inspections and a single level of assembly. Drilling down further, I can see the actual shop floor document. All the details of the incoming inspection are printed on the task card. The technician will now be responsible for performing the incoming inspection and normally doing a checklist of the inventory that's attached to the engine itself, so the QEC and LRU items. Once that's done, we'll proceed to the next step, which is uploading the engine technical data. We initiate the upload of engine technical data from the IFS data migration tool. This is an example of the type of data we would be working with. As you can see, we have a list of tracked part numbers, serial numbers, and the time and cycle data. We initiate the upload by selecting that file. So once we start the migration job, we can see the end result will be all of those part and serial details will be loaded into the IFS system. Navigating back to the component life window, we can see the part and serial details now loaded against the engine structure. Now that we've uploaded the engine configuration, we can finalise the initial work scope for the shop visit. I've gone back to the Define Work Scope window, and you can now see we have a fully blown out structure, engine structure visible. To modify my maintenance level, my initial maintenance level, I can select the module that I want to work with, highlight the maintenance level that I want to apply, in this case a quick turn, and use the Select Maintenance Level option. I'll be prompted for a reason that I'm updating the maintenance level. When I select OK, that change will take. The second part of setting our work scope is to finalise our tasks. Our tasks can be divided into two separate areas. These are SB and AD tasks and also LLP part replacement tasks. For LLP tasks, you can see that I've set a minimum release life for this shop visit of 7,000 cycles. Any LLPs that are installed that have less than that minimum release life associated with them will be highlighted in green here. I can then choose to acknowledge the fact that I need to replace those LLPs, save my changes, and LLP replacement tasks will be created. In terms of my modification work scoping, you can see that I have a full list of all modifications associated with the engine type that have not yet been complied with. I can select which modifications I wish to include in the work scope, save the changes, and this will generate job cards for the technicians to record compliance with these SBs. We can now release the finalised work scope, which will in turn create the additional shop orders and task cards for this work order. This finalises the Gate 0 process. We'll now move on to look at booking time and reporting usage of tools during the disassembly in Gate 1. The shop floor workbench is the IFS screen used by technicians to report all work they're performing on the shop visit. Let's start by signing in using our employee ID. Once signed in, I can scan the task card to retrieve the details of the operation I wish to report on. Once in there, I have a number of options. The first thing we'll look at is reporting usage of tools. I can either do this manually using the new icon, or I can confirm that the tool allocated by the Advanced Planning Board has been used by using the Copy from Planning function. The next thing I can do is digitally sign off multiple work guidelines. This can be done at two levels. Either a first level technician sign off or a second level inspector sign off. Finally, I can report time on the operation. I do this using the start production just to clock into the operation. As you can see, this can be done for multiple employees at once. And when I'm happy that the operation has been completed, I can use the approve operation function to finalise the shop floor reporting, which will both close the operation and also stop all time being booked to the operation. We'll finalise our discussion on Gate 1 processes by looking at how dispositions are entered into IFS. Dispositions are essentially inspection results. I've navigated back to my Camro interim order structure window, where I can see a full listing of all of the piece parts that are available for me to register results against. In this instance, I'm going to choose the air starter. When we navigate to the disposition shop order screen, you can see that by default we've retrieved the part and serial details from the electronic data for the engine received from the customer. And by default, we've specified a disposition code of not yet dispositioned. Let's choose to disposition this part as serviceable and to be reused. I'll change the disposition code enter any comments on my findings, change the condition code of the part, and save the record. At that point in time, I can record the fact that the parts have been identified, which will finalise the disposition of this particular air starter and reserve it to the assembly shop order for the rebuild process. You can also note that it's possible to record the level of inspection we have performed on this particular component. At the conclusion of the disposition process, a part serviceability tag will automatically be produced. Let's have a look at one more disposition shop order to see some of the more advanced functionality that's available. As you can see, this particular part we have said requires some repair. The LLP Tasks tab will inform us of any LLP replacements that are required on the part number. Similarly, under the Modifications tab, we can see any modifications that have been called up on that part under the work scope and choose whether or not to include them in this shop visit. Under the Discrepancies Code tab, we can register all the different discrepancies found for this particular item and choose whether or not the part will go to external or internal repair. Under the Repair Codes tab, we can select the repairs that we're going to request be performed on this part, either by the external vendor or internally. Once I approve the disposition line, it will create a repair order against the external repair vendor, which we can view through the purchase order link. Let's have a look now at the planning and scheduling view of this particular shop visit. We've got two ways of viewing this in IFS. The first is as a milestone-based view of the shop visit, and that's what we're looking at here. And you can see we have a number of technical milestones split into gates, and against each milestone we have the ability to record start dates, finish dates, as well as contractual start and finish dates. This is used mostly for customer status reporting, but also for cost and revenue aggregation and reporting for the shop visit. One additional feature we have available here is the ability to enter clock stop events, and these can either be flagged as excusable delays or not excusable delays. The second planning tool we have is what we call the Advanced Planning Board. This provides a detailed hour-by-hour plan for performing the operations associated with the shop visit. You can see the shop visit represented in the left-hand panel of the screen with the different dependencies between disassembly and assembly operations, and if I drill down further, I can view the individual sign-off steps. In this case, the incoming transportation inspection, QEC removal, clean and inspect. The colour coding against each step indicates the status, and as you can see for these particular operations, they're all released and tardy, indicating that we have some sort of a resource scheduling problem. I can see where those problems may arise by viewing the possible resources for each operation. This gives me a balanced load chart for each type of resource, with the green levels indicating how much resource is being consumed and the yellow levels indicating how much resource remains available. We're now moving into the Gate 2 part of the webinar. Gate 2 involves three main sub-processes. The first is chasing and receiving external repair orders in for parts that have been dispositioned during Gate 1. And here's an example of the types of parts we may be chasing. We've got some Stage 6 blades here, which were serialised, and we're looking at the Register Purchase Order Arrival window. During the receiving process, we've got full support for registering alternate or exchange parts that are supplied instead of the originally provisioned part. The second process we'll be performing during Gate 2 will be monitoring and performing any internal repairs. So these will be for components that were removed from the engine, deemed to be unserviceable, but are being repaired through internal processes rather than externally. And this is an example of an internal repair shop order. The major activity of Gate 2, however, is going through the process of accumulating and marshalling the parts for assembly. We've navigated now to the assembly shop order for the top level assembly of this shop visit. And you can see from here that we have a number of part demands listed. We have the original G90 disposition engine part, which has now been reserved, along with the air starter that we looked at earlier, which is now reserved back to the engine. On top of that, we have demands for a number of expendable items, which are grouped in build kits, as we can see through the build kit part number here. We can also see through the status of the material demand that these are currently released, which means there's no hard allocation for these parts. These demands can now either be satisfied out of stock or purchase orders can be automatically created to order the parts in. During Gate 2, there are two major activities that are performed in the system to ensure that we can track who has authorised parts for installation into the engine, and also that allow you to perform conformance checking on the parts selected. If we look at any of these parts that are currently reserved, I can highlight these parts and flag them as having completed marshalling. This will update the checkbox and also store the user ID in the history logs to ensure we have traceability of who performed the marshalling. We can also run a preliminary conformance check on this particular module. And as it says, this will validate that the component assignments for this particular assembly meet the conformance checks set up within IFS. Once the conformance check runs, any warnings regarding the conformance will be displayed and they can then be reviewed and corrected before the parts are issued. I'll now proceed to fully reserve and conformance check this engine in preparation for issue of the materials to assembly when we'll start the Gate 3 processes. I've now finished processing the material accumulation for this engine shop visit and we're ready to proceed with assembly. You can see that the material state for the assembly shop order is completely issued, indicating that all material demands for the build have been satisfied. Before we go ahead and actually process the assembly, I'll touch briefly on non-routine operations. You can see we have operation number 1000 registered against this assembly shop order, and this has been indicated or flagged as a non-routine operation. At the time that we created the non-routine, we've also specified that a certain set of work needs to be done to correct the fault that has been found during the assembly process. We can now proceed and print off a non-routine task card, which will then be signed and stamped and included in the job pack as with the routine task cards. Moving on to the actual assembly function, engineers and technicians report time and tool usage for assembly using exactly the same shop floor reporting screen that we saw during Gate 1. To finalise the assembly process, we select the manual receive option. For each module, we only have to enter the location number that the completed module will be received into, a batch number, and the new condition of the module. When we save the receipt transaction, part tag report can be automatically printed. That completes the assembly process. We'll now move on to Gate 4. In particular, looking at the process of putting together the document work package and also performing final conformance checks. Let's start by reviewing the SBs and other modifications that were included in the work scope. As you can see, the SB that had been included has now been marked as complete and can be signed off. During the marshalling and accumulation process, preliminary conformance checks were run against each module to ensure the parts issued were of the correct status to facilitate this assembly process. During Gate 4, a final conformance check can be run to ensure that all conformance issues have been resolved. Any issues that are still outstanding will be displayed in the final conformance log, where they can either be resolved or approved. The final conformance check also generates the on-log details. This contains the details of the engine and the configuration it holds at the time it is delivered back to the customer. In this window, we can also see the details of the engine as it was expected to be received from the customer's data, what was actually received during the disassembly process, and what was reserved to the engine in terms of material during the assembly process. In a similar fashion, the modification history window displays a snapshot of the current modification status of the engine, with every SB and AD being reported as previously complied with during this shop visit, or NA this shop visit. This outgoing configuration data can be displayed in a number of standard reports, such as the engine configuration status report, a modification status report, LLP status report, controls and accessory status report, airworthiness direction status report. Alternatively, all the data can be exported in electronic format so that it can be easily uploaded into the customer's configuration management system. Finally, all the documentation associated with the shop visit is available under a document package. This will include both scanned versions of reports produced from IFS, such as the Engine Configuration Status Report, or the scanned version of task cards once dirty fingerprints have been applied, or they may be documents that have been edited in a tool such as Word or Adobe Writer and checked into the document management system. From the document package, they can easily be reviewed, edited, or released and frozen. We'll finalise our webinar today by talking briefly about the contract management system and customer invoicing functionality. The contract definition within IFS supports a number of different commercial arrangements, such as cost plus material or external repair pricing, lump sum by maintenance level labour, actual hours based on an agreed contract rate for labour, or a number of other different types of pricing. When costs are incurred during the shop visit, they are logged and are visible in the transaction history window. We can then choose to apply the contract rules to these cost transactions. This will generate a number of different cost lines, reflecting summarised cost by cost type and module, and sales lines which represent planned invoice lines, again by module. The accounts receivable staff can review these proposed invoice lines, amend them if required, transfer them through to the customer order for invoicing.
Thank you, Andrew, for the presentation of the Complex Assembly MRO solution or engine overhaul. Don't forget, if you have any questions, type them into your questions box below. We can answer any that come in during the webinar while the chat, and we'll have a full questions and answer session at the end of the presentations to cover all your questions. Now we move on to the second demonstration of the webinar, that's a corporate performance management. So over to Roll Prince, who will walk you through the software solution. And don't forget to keep those questions coming in.
Welcome to this IFS CPM webinar. CPM stands for Corporate Performance Management and allows management to manage their business through connected cockpits. We use the terms map, monitor and manage to explain our solution. MAP stands for Mapping of Workflows, Organization Units and other aspects of your business, where monitor stands for KPIs, allowing you to monitor the performance of these maps. And with manage, we allow users to really manage, act on underperformance. And that's why we don't call our screens dashboards, but we call them cockpits, because the user has the ability to do something with it. Okay, imagine the complexity of your operation. That looks something like this. And if you only have this, you can imagine that that guy on the chair over there, it's quite hard to manage your operation. By the way, does anybody see where the blue ball ends? It's hard to see, but I've tried to track it down and I've found that around here in the bottom it ends. But this is not the way you want to manage your business. So the way we tend to do that is by those management connected cockpits. Now I would like to show you the Engine Shop examples, where we have created different cockpits for different roles, and they're all connected through in the heart of CPM. For instance, we created personalized cockpits for the Vice President, for the Manager Technical Operation, for the Continuous Improvement Manager, and so on. So I would like to show you two different cockpits of the Vice President and of the Manager Continuous Improvement. Let's go to the software. That's beautiful. CPM is a completely web-based application, so therefore you only need your browser to access it. As you can see, I navigated through the website and now I can use my own credentials to log in. You can use the S button over here as well, which allows you to use single sign-on, so you don't have to re-enter the same user and password. In this case, I log in as the Continuous Improvement Manager, and I'll do that by clicking this button. As you can see on this landing page is that CPM is a completely personalized environment, where in this case the Continuous Improvement Manager has access to a certain set of cockpits or pages here on the left side, and he has only access to the data which he's allowed to see. So you can set this up according to the governance structure of your organization. You can see here on the right side that he's got an immediate insight into his actions. This is the manage step. So for instance, if somebody asked him to look into the underperformance of a specific part of the business, he'll immediately see that over here on this landing page. Okay, let's start by looking at the first cockpit. It's called My Performance. Okay. This My Performance cockpit is being created to start up the day, and in the morning you don't want too many colors, too much going on there, because it will be too busy. You're just awake. So what we emphasize is that you have an overview here of the 4 most important indicators, and you will have an overview of the assets you want to manage. So if we look at the left side of the screen over here, you'll see the most important assets of the engine shop. Of course, we've got engines or APUs. We've got different types of engine types. We've got different work scopes that apply to these engines. And we can filter on work in progress or completed engines that are finished. And then over here, this is what the actual work, where the actual work is on. The engines and the engine's IDs. The way this is sorted is that the worst performers are always on top. So you do not have to search for the problems. The problems will automatically be there. And if you solve these and your list over here is green, you know you've done a good job and you've got a relaxed day. In this case, we've got one engine over here that's showing red. To finish this list, over here we've got the financial types. Because this cockpit is being created with 3 financial indicators, margin, revenue, cost, we thought it would be a good idea to filter them on the different financial types. And the last indicator over here is total turnaround time. Of course, it's important that those engines leave the engine shop within the planned or the forecasted or the contractual date. Okay, so the way we navigate throughout this is that if you click on something, you will see that the engine ID list changes. For instance, if you only want to see the work in progress, you click on it and you can see that the work in progress will change over here. Or if you want to see the completed engines, you click on that and this list changes. Once you click on an engine, you will see that the rest of the cockpit, so all the KPIs and the charts, will only show that engine. So in this case, we can see that this color is red, because the total turnaround time and margin both are underperforming. Okay, so this is the first cockpit. Let's continue and have a look at the second cockpit. This cockpit is called My Engine Shop Performance. And as you can see, this one is structured almost the same way as the previous one. On the left side we have the same structure, and the way you navigate through it is the same way. So in this case, let's look at the PTT engine, which is underperforming. And over here we have a chart that shows the man hours. Over here we've got a chart that shows the same man hours, but then in a trend line. And under that we have the engine shop cost in the 2 different categories. And over here we've got the test cell cost. If we go below that, we see the turnaround times, and we see the turnaround times in terms of actual, planned, historical actual, and forecast. And over here we see the test cell turnaround times. If you want to change something, for instance to analyze further in the man hours, in the time trend, you can open the designer of this chart. That will bring you into this screen, where on the left side you will have all the dimensions and the indicators, and over here you can set them to this chart. So for instance, if we don't want to see this per weeks, but we want to see this by day, we can delete the time week here, we can drag and drop the time day in here, and then we will have an overview on day basis. If we're not happy with this view, because let's be honest, in the end this is made up data and we want to not save this view, we can close it like this and we'll still have our old week view. You can do this for all the charts you see on this page, and hopefully this gives an overview about the engine shop in terms of man hours, cost and turnaround time. Okay, let's go on to the next one. I want to show you as many cockpits in a limited amount of time. Let's go to the My Improvement cockpit, which for the first time shows you the BizMap. The BizMap is actually at the heart of our solution. Let me maximize the BizMap for you by clicking on this button. In this case, we see the BizMap. The BizMap is most easily read from right to left. Therefore, I zoom in to the stakeholders. Over here, we stated the stakeholders in terms of value and constraints. These stakeholders are essentially the reason why your company exists. And you want to show to your stakeholders in terms of results how you are performing, how you're doing. So that brings us to the second set of results. We bucketed the results in 3 buckets: performance, finance, and compliance. Because in the end, managing your business is all about balancing between performance and compliance/risk, and that in the end will generate your financial results. If we look at these result areas, for instance, turnaround time, productivity, material availability, or revenue and cost margin, these are easily translated to indicators. So here we make the first step to indicators. Okay. In the end, every business, as well as the engine shop, has got customers. And we bucket these customers in 3 buckets: airlines, OEMs, and third-party ones. These ones are easily configurable and show you how you are doing on the customer, perspective. And in the end, you'll serve your customers through different channels. We bucketed these channels in contract types, different, hopefully for you, recognizable contract types, delivery channels, and communication. How do you communicate back to your customers? And in the end, you deliver products and services to your customers. These we bucketed in resources and in a different engine or APU types. Okay, so let's go one step deeper into your operational process. In this case, you can see that in this solution, we took the gate approach. So from gate 0 to gate 4 will be the core process of this engine shop. And as you can see the performance in terms of coloring. Green, you don't have to worry about it. Amber, well, it's not going great. And red, you're underperforming there, so you need to devote your attention to the red activities. And your factory or your core process has got management processes, as stated on top, and it's got support processes. And you need inputs and suppliers to create the products in your core process that goes through the different channels, through your customers, and in the end will generate the results which will satisfy your stakeholders. So with the BizMap, you will have a complete overview of your business on one cockpit. Okay, we call this cockpit not the BizMap or the strategy cockpit, but the improvements cockpit, because in this case we're logged in as the continuous improvement manager, and he will have an overview of all the indicators. For instance, if I click on productivity over here, I will see my productivity indicators with a trend graph. But what I will see as well are here the improvements. And the improvements are the different actions that the different managers and stakeholders within the organization send through to each other. And it's the continuous improvement manager's job or responsibility to look after these improvements, that they are correctly implemented and that they do have the wished effect. Okay. Okay. Let's have a look at the My Production cockpit. In this case, we zoom in into the... We'll do that again. Let's have a look at the My Production cockpit. Over here, we zoom in into the core process, as it's central on this cockpit. As you can see, we've got the same core process as on the My Improvements cockpit. And over here, under that, you'll see the production performance indicators, and here to the right, the availability performance indicators. And here on the right side, you will see the same filter assets as you saw in the previous cockpits. So you can still use the same way of navigating to select the underperforming engine. Okay, if you click on a specific gate or workflow activity, you will see only the performance of that specific activity. And the indicators will give you the context you need to really investigate the underperformance and where you need to improve. Here in the right midsection, you'll see a data analytic web part. Over here, you can really dig down deeper into the data. For instance, you can drill down into another dimension, or you can select another dimension at all, or from a different indicator. But if you click a different indicator, it's automatically selected in this list. What happens as well if you click an indicator, over here on the right side, there is an information box where we state the definition of the indicator and the way it's calculated. There can never be a discussion about the way it's calculated. The discussion should always be about the underperformance. And hopefully this cockpit will help you and your colleagues managing the core performance the performance of the core process. Another thing which I didn't show you yet is that you can drill down into the workflow activities as well. Okay. We only have a set time frame, so let's continue and look at the next page, which is the My Finance page. As you can see, the My Finance page is basically the same as the My Production page, only you'll see that over here there are financial types and over here there are financial indicators. And you can see that the coloring of the process is different because we only look at the process from a financial perspective. The rest of the navigation, the rest of the cockpit works exactly the same as in the previous cockpit. Okay, let's go to the next cockpit. This cockpit is the My Shop Visit cockpit, and this one gives you a different overview of the assets of the indicators as you have seen before. This will give you a bit of a more detailed information about your engines and about the indicators that are connected to those. And over here you can drill down into the engines or into the indicators in a different way. Okay, let's go to the supply chain cockpit. The supply chain cockpit gives you an overview of the supply chain, of course. And over here on the left side, we grouped the suppliers into two buckets, internal suppliers and suppliers. And what you can do over here, if you click on this one, you can sort it that the underperforming suppliers are on the top. And if you click on these, you will see that the indicators are only showing the performance of this supplier. And over here you can see the performance of the engines on this indicator. Over here on the right side you see the indicator and the trend chart. And over here you can see the actions that are potentially related to this indicator or supplier. Hopefully this gives you a complete overview to manage your supply chain. Let's go to the next cockpit, the My Stores Management cockpit. The My Stores Management cockpit gives you an overview of your inventory. Here on the left side we use commodities to group different parts. And here on the bottom you'll see the real part numbers that are currently in the system. Here on the right side you will see the different indicators that relate back to the commodities. And if we click any or one of these indicators, you will see that the trend chart changes. Here on the bottom we've got an analytic chart where you can, which you can configure in such a way that it gives you immediately the information you need to manage your stores. Okay, let's go to the next cockpit, the HR cockpit. The My HR cockpit gives you a complete overview to manage your resource pool. We grouped the resource pool for this engine shop in two categories, the engineers and the technicians. And here on the bottom we show the different time types. Basically the time types are the different codes on which personnel can book their hours. And over here it's stated as well if it's either productive or if it's leave. As an additional filtering we put in overtime or normal time because you want to manage that in a different way. And over here we've got the different indicators that are set up by the different time types and overlaps the labor classes and the overtime. So it goes from available hours to productivity, number of employees, etc., etc. If you click anywhere, what you automatically will see is that the chart, as well as the analytic web part, will change according to that selection. What you can do here, obviously as well, is that you can change it to show, for instance, only the employees. So you can change the dimension, which gives you an overview. For instance, if we want to look at leaves, we can see that this mister over here has got 200 leave hours booked. Probably we need to look into that. Okay. Let's have a look at the last cockpit I want to show you in this webinar. That's the My Tooling and Equipment cockpit. The My Tooling and Equipment cockpit will give you an overview of your tools and equipment related to a work center. This list over here is sorted in such a way that the underperforming work centers are always on top. So in this case, if we click on, let's say, this work center, we can see that these tools are underperforming and are related to that work center. If we then click on this one, we can see specifically these indicators coloring accordingly to that one tool. And we can go back by only clicking this one, and we can see it over the whole group, the whole work center. Here in the bottom, we see the trend chart. Here we see the information box, and here we can see the data analytic, which gives us the capability to drill down into this data to, for instance, tools. Okay, so hopefully this gives you an overview, the overview you need to manage your tools and equipment.
Thank you, Roel, for the demonstration of the Corporate Performance Management solution. Now that concludes the live demonstration sections of the webinar, and would like to thank you for attending, and I hope you found them interesting. We're now moving into the QA section of the webinar, so please type your questions into your question box located below your main conference window. You'll only see your own questions. We've had some questions coming in during the webinar, so we can make it started with these, but please continue to type in your questions. Thank you very much.
Okay, this is Espen again. So thank you for listening in on the webinar regarding IFS applications, engine overhaul solutions for the 21st century. Now we're now into the Q&A session, and with me here in the office I've got Brendan Figures and Tony Lowe. They're subject matter experts on the corporate performance management product as well as the complex assembly MRO module and the engine overhaul solution. So we've got quite a few questions that's come through during the two demonstrations. So first of all, I'd like to thank Andrew Simpson and Roel Prince for the demonstrations. They both worked with our team in Dubai supporting Emirates, and the solution that you've seen is actually what is installed with Emirates Engineering currently. Now, a couple of the questions that we've had that's come in is whether the software can support only GE type engines, or if it supports other engine manufacturers as well. So I believe the question goes to Tony. If you can elaborate on whether IFS applications support any type and model of the engine, and also what other equipment, if possible, you can manage with that solution.
Hi. No, the solution is not specific to GE engine types. It can support any engine type that's on the market, be it Rolls-Royce, Pratt & Whitney, Lycoming, etc. It doesn't really matter. The software is data-driven, and therefore it depends on the data aspects that is required to support the engine. Furthermore, as Andrew alluded to in his part of the demonstration, the application can also support APUs or landing gear, or other even more complex types of equipment that may be installed in an aircraft that needs to be monitored on a regular basis, like ejection seats and things like that. So there's various components that the complex assembly capabilities can support.
Okay. Thank you, Tony. Another question for you, Tony, is whether alternate parts can be identified as part of the disposition process. Can you share a few words around that?
That's the whole idea of having our position part. The position part is basically an indicator that there's a structure position in a component that can either be filled with a real part number or an alternative part number against the real part number. And therefore, yeah, the answer to the question is yes, it is easy to identify alternative parts, because as part of the identification of the part number and serial number, you're actually determining whether it's an alternative part that has been installed in the engine or not. Thank you.
Okay, thanks, Tony. Question for you, Brendan. The second demonstration that we had was around the corporate performance management. And one question that came in sort of relates that to a BI tool. But what makes CPM different to any sort of normal BI tool?
Yeah, I mean, on the face of it, it looks like a business intelligence tool. But really, your BI is a byproduct of you modeling a strategy, so the biz map that we all showed, where you model the value chain, where you model your processes and your organizational hierarchies and definitions, and your governance structure. And as you do that, as you model your organization in CPM, a byproduct is the cockpits and the business intelligence that you're seeing on top of it. So that's what makes CPM different to other BI tools on the market.
Okay, thank you. And furthermore, there's a second question on the corporate performance management and whether you can integrate that solution to other data sources and how you can add more indicators.
Yeah, so two things there: integration to data sources and add more indicators. The first is, yes, you can add other data sources, and particularly in aerospace and defence, our customers do have multiple data systems, whether that's a separate finance, HR, and MRO ERPs, or even getting data from devices such as engine data. So yes, we have to be able to integrate to multiple data sources, and can do that through the extract, transform, load model within CPM. Adding more indicators, again, is easy. You model those indicators as you develop your strategy map, your biz map, and your processes. So as you're identifying how you're going to measure those objects within your organization, you then create your indicators and you model them. And that's what generates your BI as a byproduct of that.
Okay, thank you. Tony, I've got one question for you here coming through. The question is, are external repairs only for work performed by external vendors, or can internal support organizations, for instance, the welding shops located at different sites, be used as external vendors for repair?
Yeah, if the organization has a dispersed support organization, so it's got welding shops on different locations or plating shops on different locations that require to support the engine, then we can handle it as either an internal vendor, if it belongs to the same company and so on, or we could handle it as an external vendor, and the software would handle them both as a customer and a supplier in that respect, which would allow for standard inventory transactions to create a purchase order on the one site and the customer order on the other site, and allow you to track the interchangeability or the movement of parts, between the two different maintenance organizations. And we can handle it both as an internal organization or an external vendor, depending on the business requirements.
Okay, thank you. We're coming up to the 1 hour mark now, but we've got time for one final question. And the one that came through is who's actually using the software today? And I'll try to answer that myself. The engine overhaul solution, we started out with GE Aviation back in the early 2000s, and together with GE Aircraft Engines and what's now GE Aviation, we started developing this tool. Finnair, which is now GA Telesis, installed this and it has been using it for more than a decade now. Alitalia Maintenance Systems, Hindustan Aeronautics, Honda Aero in the US, Emirates Engineering is the latest addition to this tool set, and that was implemented in 2014, went live just before Christmas last year. So there's quite a list of industry-leading companies that has been part of the development, testing, and has been actually using the system now for, as I said, 10, 15 years. So that is all that we have time for today. Now, the presentations, the webinar will be available on the Aircraft IT webpage on Monday. There will also be the PDF versions of the presentation that I had at the start of the webinar. So with that, I'd like to thank Aircraft IT for hosting this session with us. I would also like to thank Andrew Stimson, Roll Prince for the excellent demonstrations, and also Tony Lowe and Brendan Viggers for supporting me at the Q&A. So thank you very much, and have a good day.